Powder bed fusion. The powder bed fusion is a process where 3D object is created by adding and fusing powder material layer upon layer. Powder bed fusion uses either laser or electron beam as a heat source to sinter or melt the powder material. There are different printing techniques or methodologies commercially available based on the PBF principle. These are selective laser sintering, selective laser melting, direct metal laser sintering, electron beam melting, selective laser sintering. SLS is a trademarked term for PBF LB where powdered polymer materials such as nylon and polyether ketone are sintered to fuse together layer upon layer. The SLS process is used to produce prototypes as well as durable functional parts with complex geometries. Selective laser melting (SLM). Unlike SLS, SLM uses laser to fully melt the powder rather than sintering it. The melted powder particles formed by scan laser solidify to form a layer of the component. The process is repeated layer upon layer to generate 3D object. Direct metal laser sintering. DMLS is a trademark name which is similar to SLS but uses metal powder instead of plastic. The process usually sinters and fuses the metal powder layer by layer. Note: in DMLS, despite the term sintering being used, full melting of powder material can also be achieved similar to SLM. Electron beam melting. EBM uses electron beam to melt and fuse the metal powder. The process is carried out under the vacuum. Prior to melting, powder is preheated to approximately 1000 degrees centigrade. Note: preheating of powder minimizes residual stresses and distortions and thus reduces the need for support structures and stress relief heat treatment. EBM process is faster than SLM or DMLS and provides better material properties due to preheating of the powder. In the case of EBM, raw material has to be a metal as electrons excite the molecules in the metal, resulting in rapid but controlled heating. This facilitates to near instant melting and consolidation of the powdered metal. Typical 3D printer based on powder bed fusion processes LB-PBF and EB-PBF has following parts. Note: you will see a 3D schematic representation of laser beam and electron beam powder bed fusion process. Working principles of both LB-PBF and EB-PBF is similar, however, there are certain differences in the printer architecture. Execution and end result which is attributed to different energy source. Laser system. Laser system for LB-PBF printer comprises laser, optics, galvanometer scanners. Galvanometer scanners deflect the laser beam using rotating mirror in X and Y direction. Beam forming is recognized through collimation and focusing lenses. Note: industrial LB-PBF machines of today use fiber laser which power ranges from 100 to 1000 watt. Some manufacturers use continuous lasers and some use pulsed or modulated lasers. Multi-laser system with 2 or more lasers have been developed to increase productivity. Electron beam system. Electron beam system or EB-PBF printer includes electron beam, column, electron gun, tungsten filament and lenses, astigmatic, focus and deflection. The electron beam is produced in the electron column by an electron gun, which extracts electron from a tungsten filament under vacuum. Beam forming is facilitated by collimation and focusing lenses. Note: electron beam gun can generate a high energy beam up to 3500 watt. Controlled environment system. Laser PBF printer employs inert gas flow system which supplies and controls the flow of inert gas, such as argon in the build chamber. Note: an inert atmosphere is required to prevent oxidation and push away process smoke and particles from the fusion process using the gas stream. Electron beam PBF printer employs vacuum as a controlled environment. A typical vacuum system comprises vacuum chamber, pumps, leak detector, and control valves. Note: vacuum is required to ensure that the beam is not scattered by residual gas molecules. Vacuum also prevents the powder from oxidizing when heated. Powder reservoir hopper. A reservoir contains and provides fresh powder material. Note: method of powder delivery may vary from one machine manufacturer to another and can be gravitational or adjacent to the powder bed. Roller or recoater blade. Roller or recoater blade spreads the powder uniformly over the build platform. Note: direction of recoater blade motion varies from manufacturer to manufacturer, such as side to side, back to front, and pivoted with rotating arm. Build platform. Build platform supports and secures the base plate on which the object is being printed. The platform moves vertically downwards in Z-axis after every layer is fused. Build plate. Build plate supports the powder material and the object being printed. Build plate also acts as a heat sink to dissipate heat generated by the fusion process. Powder dispenser. The powder dispenser moves vertically upwards, allowing the recorder blade to spread a layer of metal powder on the build plate. Powder collector. The powder collector moves vertically downwards to accommodate overflowed powder as the recoater blades sweeps over.